Right, so here's the module repaired. I've replaced the bridge rectifier. I've also fully reverse engineered the module, so I know how it works. I know what the two ICs are. And I've replaced, as I say, the bridge rectifier. I've left it standing off the circuit board just to let some air flow underneath it to help cool it. The legs are really quite sturdy, so they're not a problem, and it doesn't take up any more space than it originally did. So in a minute I'll show you what testing I've done, and then I can get it shipped off back to Mark. Oh, I should say, if I'm buying components for repairs I'm using myself, just for mucking around on the bench, for example, I'll buy them from AliExpress or eBay or somewhere like that. On projects like this, where I'm actually giving it to somebody to use in a proper setting, and I want to make absolutely sure that they're safe, then I'll buy them from a reputable dealer. In this case, I think it was CPC Farnell, but CPC or Rapid or somebody like that. Right, okay, so I'll be back in a minute with the test that I've done. So here we are on the test track. I'd like to give this a bit of a burn-in test before I send it back to Mark. So what I'm going to do is just leave it running for an hour or so, and then check its temperature and check it's still running at the end of the test. I've set up a quick test layout here, but I've only got one diode and one track interruption, but I've adjusted the timer on the unit to let the loco run just long enough to get to the end of the track and not jump onto the floor, I hope. But yeah, we'll see. I've noticed on the website there's a mistake on the diode drawing. For this circuit to work, the diodes should both be organized so that the white ring, or the silver ring in this case, points towards the center of the track and the power takeoff. So let's give it a run and see what happens. See what happens. That's confidence, eh? So it's sitting on the dead track at the moment, and now she goes out and back and out and back. What I don't like about these units, this loco shows it quite clearly, is when it stops, it stops. What the unit does is it's switching the input voltage basically straight to the output voltage, and then changing its orientation. But it doesn't do a soft start. It just does a full power in one direction, stop, wait, full power in the opposite direction. And you can hear that when the locomotive stops just now. And it does a sort of Casey Jones. I don't like that. It might not be as bad on a locomotive with counterweights in the motor, but I'm sure the circuit can be improved on. I have reverse engineered the circuit. I know how it works, and I might have a go at modifying it, but that's for another day. Right, so I'm going to leave this running, and we can come back in an hour, maybe 2 hours, depending how big a lunch I've got. I'm not going to torture you by making you watch this. See you in a minute. So here we are after 2 hours running, backwards and forwards on the test rig. And this is a thermal image of the controller. So on this image, the white shows the very hottest areas, and the darker colors are the coolest areas. Now it's not as bad as it looks, because the very whitest areas on here, according to my camera, are 50 degrees centigrade, although it doesn't show in the screen capture. So the hottest items are this IC, which is actually driving the motor itself, so you'd expect it to be passing a lot of current. And it's interesting, you can see that the heat is concentrated right in the center of the device, where the die would be. This item down here is the 5-volt regulator for the microcontroller and the driver. And this item is the bridge rectifier that I replaced. And again, after 2 hours running, it's reached a constant 50 degrees centigrade. So I think that's a pass.